Now, before we get into the details of another application of the derivative, I wanted to do something to kind of give you a visualization of what this topic that we're about to do is all about. Now, if I were to ask you what type of function is this the graph of, right? So like you see this graph on the screen, and I would ask you what type of function do you think would have this graph? I would say maybe 9 times out of 10, or maybe 10 times out of 10, students would say that this is a linear graph. And that's a completely uh, valid answer, right? I mean, there's no evidence otherwise, right? However, it turns out that this graph is actually not linear, and I can show you why. So now I'm using the program Maple that I've used in a previous video just to help you visualize certain things. Well, I have the ability to zoom in and zoom out on certain parts of the graph. So I've really zoomed in on a certain part, and I've zoomed in so close that to the casual observer it looks like just a line. Now let me zoom out. And as I zoom out, you start to see that this, in fact, is not a linear function. It is indeed a non-linear function that is quite, curvy. In fact, it has lots of relative maxes and mins, and there are some inflection points and all that stuff going around. So it definitely isn't linear. Again, let me show you what I did. I took this very non-linear function and I just picked a portion of the graph, any portion of the graph. So the one that you saw at the start was somewhere around here. Let me pick another part. Let's say I did this part. I can zoom in on that part. And if I zoom in close enough, it looks like the graph of a linear function. But actually what you're seeing, well, clearly you're seeing a line. What you're seeing is actually the graph of the tangent line to that function at that point, right? Now, in more advanced math classes, the concept of the derivative is a little bit different. In fact, what we say is that a function is differentiable if locally, meaning when you zoom in on a particular point, if locally it can be approximated by a certain linear function. Well, what linear function is it? It's the tangent line, right? So when you zoom in, and let me pick another portion of the graph, just to emphasize that this has nothing to do with where on the graph I'm zooming in. It's just the fact that the function is differentiable at every point here. So no matter where I zoom in, let's say I pick this part. If I zoom in on it, you just see like the fact of zooming in, it just flattens it out. Like, isn't that remarkable? It's like you've put the function under a microscope and you've zoomed in, and all you're seeing is these bunch of lines, right? No matter where you zoom in, you'll always see these lines. So whenever a function is differentiable, what we say is locally it can be approximated by a linear function, and that linear function happens to be its tangent line. So that's what we're going to explore in the next video, but I just wanted to do this to kind of give you a sense as to, what do we mean when you hear the phrase linear approximation? You're talking about in a very kind of small neighborhood or small region of a particular curve. As long as that curve is differentiable, then you can always approximate it by a very special line, which is our tangent line. And then that will be our next application. So if you want to see the details of that, well, why wait? Just hop on over and we'll have some fun with tangent lines, but in a slightly different way. See you then.